Hello and welcome to Entec's webinar series in the Business of Better, enabling a sustainable future in plastics through application development. Today's webinar has been pre-recorded to eliminate any technical glitches. All of today's presenters will be available at the end of the webinar today to answer any questions you may have. During today's presentations, if you have any questions, please feel free to send your questions through the Q&A box on the upper right of the webinar. Before we begin today, I would like to ask that you take a brief moment to read our legal disclaimer. What you can expect from today's webinar is an introduction to who Entec Polymers is, how Entec is committed to sustainability, how we view sustainability within our core markets, and what Entec can do to help you achieve your sustainability goals. What started as engineered technical polymers has become what we know as Entec today. As one of North America's largest polymer distributors, we offer almost every resin available to the industry. We have a team of 11 technical service engineers with combined experience of nearly 200 years. We have nearly 2 sales reps per state. We have 7 business development managers focused on our core markets with backgrounds in marketing, application development, and technical service. And as a company that does not produce any material, the core of our business is supply chain. It's critical to have our material placed geographically favorable to customers so that we reduce long-haul trucking and limit environmental impacts. Entec Polymers is a subsidiary of the Ravago Group, and Ravago is a global leader in plastics, chemicals, and rubber distribution. Ravago utilizes over 3,000 global suppliers, which provides us with nearly 40,000 products and allows us to ship over 14 billion pounds of resin annually. And that's all made possible by our global network of 7,000 plus employees. My name is Melissa Gerchnoff, and I will be facilitating today's presentation. I'm a business development manager for sustainability and packaging here at Entec, and my background is with color concentrates, additives, and performance films. I've been in the plastics industry for the last 10 years. I'm joined today by 4 of my fellow business development manager colleagues, Alex Lashaitis, who is responsible for leading the application and material development of the North American automotive market. Alex has worked in the industry since 1991 and has a long history of working with automotive OEMs and tier molders to provide the best design solutions for materials. His colleague, Eric Farrell, is responsible for the North American automotive market for both Ravago Americas and Entec Polymers. Eric holds 25 years of experience in automotive industry with expertise in business development, key account management, and supplier business development for OEMs and tier 1s. Ed Hindi is a graduate of Georgia Tech and began his career working with molders and film companies and eventually moving on to color concentrates and additives. Ed has over 25 years in the plastics industry and is a business development manager for Entec, focused on performance films and other packaging applications. Jim Johnson has been the director of commercial plastics technology for Entec Polymers for 17 years and in the industry for 38 years, specializing in material science. In his role, Jim manages Entec's technology group, which consists of 11 degreed plastics engineers that provide technical support to Entec's customer base. Jim is also responsible for the business development of the compounding market, where his efforts are focused on impact modification and compatibilization, which will be discussed in today's webinar. At Ravago, we're proud of our heritage. The company was originally founded as a plastics recycler. With sustainability in our DNA, we've established 4 pillars for sustainability for the global organization. Those 4 pillars have been identified as recycling excellence, community engagement, environmental footprint, and strategic partnerships. And to build off Ravago's 4 pillars, Entec has created our strategy to focus on our 5 core principles of sustainability. At Entec, we're constantly challenging ourselves to incorporate sustainability in everything that we do, from the products that we supply to how they're delivered and how each one of us lives within our communities. Historically, distributors have been viewed as materials supplier, but we've designed our strategy to be a comprehensive, solutions-based approach to enable a circular economy that leverages all of our resources. Our primary goal is to redefine the distributor's role in our industry. Our sustainability pledge is to lead and inspire collaboration and to develop comprehensive sustainable solutions in plastics distribution. Our 5 principles are solution community, which is our involvement in our communities, promoting education within our community, and how we collaborate with our suppliers and customers and participate with various industry organizations. Our materials principles provides a complete toolbox to our customers of sustainable materials, including PCR, PIR, and bio-based resins. Our supply chain principle is how we are able to be more sustainably efficient while improving our customer experience on delivery and reducing carbon emissions and miles traveled. Our services principle is a collaboration with Ravago Recycling to collect and offer customers a solution for material waste through mechanical and advanced recycling. Today's webinar will focus on our development and design principle, and that's how we look at sustainability throughout the development and design phase of a product. Our primary focus for the development and design principle is to ensure that for both new and existing applications, our developments are centered around environmentally and economically sustainable options. As a distributor, we're able to take an agnostic approach to selecting material solutions through our network of key supplier partnerships that help us achieve application excellence. A primary focus for us is on lightweighting conventional products and optimizing design to facilitate recycling. And by doing so, we can reduce the consumption and provide new life to materials. Today's technology has provided advancements in bio-derived, recycled, and compostable resins that have made it easier to design structures while maintaining product integrity. In addition to the structure, we're also focusing on a comprehensive approach for this principle that extends into equipment optimization and how to improve manufacturing efficiency. Today's webinar will focus on our 3 core markets: automotive, packaging, and compounding. Before we move on and get into our first core market for today's webinar, I'd like to take a moment to review some acronyms and definitions that will be used throughout today's presentation. PCR, post-consumer recycled resins, which are those collected after consumer use and offer the most significant impact on eliminating plastics waste. PIR, post-industrial recycled resins, are derived from production processes of virgin resins. OBP, ocean-bound plastics, are plastics materials that are intercepted in coastal areas before they become marine debris. Bio-based materials, which refer to products that mainly consist of substrates deriving from living matter, either occurring naturally or are synthesized. Compostable materials, which are plastics that undergo degradation by biological processing during composting to yield carbon dioxide, water, inorganic compounds, and biomass. I'd like to now take an opportunity to hand it over to my colleague, Eric Farrell, to take us through application development for the automotive industry.
Thank you, Melissa. Hello, everybody. My name is Eric Farrell, and I'm the Automotive Market Manager for Entec Polymers. Along with my colleague, Alex Lukshitis, we have responsibility for the automotive market for application development, business development for Entec. We are both based in Michigan, and we support automotive in terms of new applications, design, OEM support, and Tier 1 support. Today, we're going to be talking about the reduction of greenhouse gas and fuel consumption through the use of sustainable polymers and what that means from an application and how it applies overall to vehicles. The concept of lightweighting has been around for quite a while, but really has started to take on a whole new meaning. And the reason being is because of electric vehicles. As we all know from the news that's been published and more of the information coming out about EVs, the goal in the United States is to have 50% of all vehicles produced and sold in this country to be EVs. So how do you get there? You get there through lightweighting. And in that process as well, you can get there through offering sustainable materials to reduce the greenhouse gas and fuel consumption. Through the evolution of vehicles going back to the original times when vehicles first came out to where they're going today, you're going to need everything in the toolbox that you can possibly get so that you can go ahead and hit those goals as you meet the EV target going into 2030. From an Entec Polymers perspective, we actually have been good sized players in recycled materials for a number of years. One of our strengths is automotive recycled nylon and polypropylene, which is produced by our sister company, Ravago Manufacturing Americas. The material that we're going to talk a little bit about from a nylon and propylene standpoint is actually a material that comes from carpet fiber. The carpet in this country is recycled from a post-consumer standpoint and a post-industrial standpoint to offer distinct materials that can be used in specific applications. From a post-industrial standpoint, the carpet that we're speaking about is really waste that comes from the producer level when the carpet is produced. We take that carpet and those fibers and we recycle that back down into a pellet, and our main focus is nylon 6,6 and nylon 6. From a post-consumer standpoint, that is actually carpet that comes off of a consumer's floor that is then harvested by a recycler, and then we take that product and turn it back into a saleable pellet that is nylon 6,6 and nylon 6. And then in addition to that, we recycle the carpet backing to use that for polypropylene applications as well. We have a proprietary process at our facility in Tennessee, and we've done a good job taking those particular materials and recycling them into a saleable pellet, and they're in use in a lot of different automotive applications. In terms of the process, I wanted to go over how it's done because I think you'll find this all very interesting. From a post-industrial standpoint, we do start with fiber, and that fiber is mostly carpet fiber, but also can come from the example that you see listed here, which is a spool. So the fiber then is recycled through a proprietary process into a fluff, and once that fluff is completed through that process, it is then turned into a pellet. As it's compounded into a pellet, during that time, we do add different additives, fiberglass, impact modifiers, heat stabilizers, and so forth, and then that creates an end product, which we'll talk about in a minute. From a post-consumer standpoint, what you see there is actually recycled carpet that we get into our facility that has come from the consumer. It's recycled in the same process of turning it from a carpet into a fluff and into a compound, and then during that process, we also add fiberglass, impact modifiers, and heat stabilizers. In both cases, those resins are used to make various different applications that go anything from powertrain to fuel applications to door handles, and it's a process that we've been doing for quite a while, and the technology is improving. From a property perspective, the material is engineered in such a way that the properties are very good and able to be used in applications with demanding requirements. Focusing on nylon specifically, what is really critical to quality in applications that require nylon are dimensional stability, heat deflection temperature, long-term heat aging, and thermal cycling. Because of the fact that nylon is a material that is very forgiving and able to be recycled a number of times, it lends itself to this type of recycled process where you can take the material and break it back down into a pellet, and then you can use it for applications like fans and shrouds, below belt brackets, air intake manifolds, and door handle cores. And during this process, we're able to take the material and take most of the additives and so forth out of the carpet, and so we can use that material in certain applications where requires those type of properties. And with that, I will hand it over to Ed Hindy, who will work on the packaging side of it.
Good day, and thank you, Eric, for the introduction. My name is Ed Hindy, and I am the Business Development Packaging Manager for Entec Polymers. Let's move right into the first slide for packaging. Regarding sustainability for the packaging market, there has been pressure by brand owners and the consumers to use less fossil fuel-based resins in packaging. Whether it's for rigid packaging or flexible packaging, the pressures are on. These pressures have resulted in new industry proposed goals for 2025 out to 2030, which as a result is putting demands on suppliers to help achieve their goals. Additionally, regional governments are discussing legislation changes for plastics and their use, and they're adding a lot of pressure for the development of products and advanced solutions. There are also commitments to the Ellen MacArthur Foundation and the U.S. Plastics Pact, which are further driving these goals in two main organizations in the packaging space. Current industry commitments are to incorporate roughly 25 to 30% sustainability or sustainable sources of material into packaging, with a long-term focus on achieving 100% recycled material, whether it's 100% recycled film or 100% recycled injection molding parts for rigid. Entec's vision is to promote sustainable solutions and ensure plastics do not end up as waste in the environment. We are promoting a circular economy and advocating for responsible behavior to protect the longevity of our environment. And the ways that Entec is promoting this are through lightweighting, incorporating recycled product, and enabling end-of-life recyclability or compostability. Moving on to the next slide. As I mentioned, one of the ways that packaging market is addressing sustainability is by lightweighting into the packaging space, i.e. thinner films or thinner parts. However, the biggest challenges for lightweighting are machinability at the end user or barrier technology, which is needed to achieve longer shelf life for the food that's on the shelf. The advanced resins and catalyst technology that are out there by the producers have allowed us to offer improved barrier resins that are recycle friendly and also promotes down gauging, i.e. less carbon footprint. In addition to resin advancements, equipment has also been evolving during this time. For example, in the MDO, which stands for machine direction oriented films, these MDO technologies provide an opportunity for mono or coax designs using all polyethylene resins with superior properties over traditional type of structures. Developments for BOPE have also advanced, as well as to replace BOPP, which is propylene, and BOPA, which is biaxially oriented nylon, as a recycled option. Another area of advancements are in extrusion, adding more layers, greater than 9, for example. 9 to 13 or 14 extrusion lines are very common now. Microlayer technology, which allows stronger films at much thinner gauges, thus reducing the material usage for the applications. Additives also provide solutions by improving impact, stiffness, barrier improvements, which can be blended into polyethylene or polypropylene layers as well. Another example where we can recycle BOPP or PET lamination films, or where you can't recycle them and replace those technologies with BOPE. The bottom line is that all these advancements are allowing for recyclability and an easier way of replacing these types of materials for extrusion producers. Moving on to the next slide. Let's now move from material reduction and lightweighting to incorporation of material in the form of recycled content. Industry targets for recycled content continues to grow and expand in the market. Whether it's for rigid packaging, which is common, FDA PCR is really the demand and is a very significant part of this market. The material is mainly sourced from high-density polyethylene milk jugs. And what we're learning in this market now is that demand increases for this material has really restricted the supply of high-density polyethylene FDA-type products. In flexible packaging, incorporating low-density polyethylene and linear low PCR is a common goal among brands, but even more limited at this point in time. Very hard to get these materials as well. As the supply stream is tight for FDA materials, we've seen success, however, on the non-FDA PCR material used in protective packagings, coalition shrink film markets, mailer bags, and retail bag applications. Moving on to the next slide, we'll shift our focus onto bioresins. Due to the demand and limited availability of recycled resins, we are seeing an increased interest and demand for bio-based resins. Also, there has been some flexibility and change in direction for sustainability goals, which now include these type of materials. Regarding polyethylene, bio-based feedstocks are derived from sugarcane, potatoes, corn, and other starches. Polypropylene, however, is derived from used cooking oils. PLA and PHA are derived from the fermentation process. The goal for these types of resins is to replace the fossil fuel-based materials while maintaining the properties and performance for the intended application, with the primary goal being to reduce the global carbon footprint. Depending on the environment in which these materials end up in, there may be opportunity for degradation to occur, i.e. landfill or compost environment. Bioresin selection is critical and will depend on the end-of-life intent of the customer. For example, PLAs are bio-based and compostable, but not all PLA blends biodegrade in landfill. Also, not all bio-based olefins are compostable, but may degrade in landfill. The packaging brand owners are promoting language in their advertising, such as all natural and plant-based materials, for example, which are well received by consumers right now. There are now many commercial examples in the market. Moving on to the next slide. In this slide, we're shifting from bio-based polymers to specifically compostable polymers. As I just mentioned, it's important to note that not all bio-based materials or bio-based polymers are compostable. To be compostable, the polymer must be able to undergo degradation by a biological process. The most common materials used for compostability are PLA or PHA, but in addition, PBAT is another material. However, some of the primary challenges here are cost, short supply, barrier, and understanding the compostability, what that really means. In addition, these materials are not compatible with polyolefins in the recycle stream, eliminating them from the recycle stream. And this is really a big issue out in the market right now regarding these materials. This is a challenging topic for our industry, and it's clear that there is a significant amount of misunderstanding when using these type of materials in various applications. In summary, the primary focus of the packaging market is on making packaging that is recycle friendly and to enable a closed loop system. Traditionally, pouches are predominantly PET laminations, and these polyester laminates do not allow for recycling. There's been a lot of work and recent advancements on this application to use the new technologies we noted in the lightweighting example slide, and to create a monomaterial package that can be recycled and is fully polyethylene in material design. While these provide excellent options, they do present some obstacles in the manufacturing processes. These all PE stand-up pouches tend to have lower heat resistance, lower stiffness, and lower optical properties. We continue to work and educate our converters on how to adapt these all PE structures on existing packaging lines. I look forward to answering any questions you may have at this time. And now I will turn over to my colleague, Jim Johnson, to discuss compounding. Thank you.
Thank you, Ed, and good afternoon, everyone. My name is Jim Johnson, and I'm the Business Development Manager for the compounding market at Entec Polymers. I'll be talking about our sustainable application development efforts in the compounding market. As you've heard mentioned in the previous sections of this presentation, sustainability is the hot topic right now in most of the markets, and that includes the compounding market. We feel that the compounding market is critical because it's really what ties all of the sustainable products together. Because with few exceptions, most of these products will need to be compounded. The push for recycled, bio-based, and compostable products is at an all-time high right now, and this presents a lot of new opportunities and future growth potential for recyclers and compounders that can take advantage of this. However, there are many challenges in the recycled plastic market right now, especially with the increased demand for post-consumer recycled plastics. Some of the main challenges that I see include the overall availability of post-consumer recycled feedstocks. This has been especially affected by the rapid rise in demand as many of the OEMs and brand owners are committing to increased use of PCR in their products. This becomes even more challenging for high quality natural colored feedstocks. There's also the issue of the feedstock quality. Obtaining contamination-free feedstock can be a challenge. And while some contamination can be accepted, higher amounts can cause processing issues, poor properties, poor performance, and has to be dealt with. Another area of concern is incompatible feedstocks. This can be a challenge, especially if you don't have the equipment or the resources to effectively identify, sort, separate, or process mixed or contaminated feedstocks. Having formulation expertise to effectively deal with these issues is required in order to produce consistent, high-quality compounds from recycled materials. These challenges create the need for compounding application development that can assist with recommending, selecting, and utilizing solutions consisting of things like compatibilizers, impact modifiers, nucleating agents, and other additives, as well as refined processing or extrusion techniques. All of this can help prevent materials from potentially ending up in a landfill. So here are a few application examples of how we can salvage recycled products using modifiers and additives and prevent them from being sent to a landfill. Compatibilizers are a specific type of additive that helps to couple or tie together dissimilar or incompatible materials to make a homogeneous compound. For example, compatibilizers can be used to couple PE contamination and polypropylene. And as most of you are probably aware, it is not uncommon to have PE contamination in PP feedstocks. And while a small amount of PE is okay, higher percentages are unacceptable and can lead to poor properties and delamination during injection molding. Adding an olefinic block copolymer to the compound can result in complete compatibilization and improved properties. In another example, a compounder was offered a very low-cost polypropylene feedstock that contained 2 to 3% EVOH contamination. They tried to compound the material but had major processing difficulties. Adding a maleic anhydride modified polyolefin compatibilizer to their formulation allowed them to produce a high-quality compound. This allowed them to utilize this low-cost contaminated feedstock rather than potentially having to send it to a landfill. Another example is using an impact modifier to boost the properties of a recycled polypropylene. After seeing multiple heat histories, the polypropylene feedstock can lose properties, especially impact and elongation, and become more brittle. Incorporating even a small amount of impact modifier can help to improve the final compound by boosting the impact and toughness and elongation properties. Going even to higher levels would actually improve those properties even more. Other additives like near-IR black colorants can also make the compound more recyclable in its next lifetime by allowing it to be better identified during the recycling sorting operation, rather than having that material get kicked out and landfilled because it wasn't able to be identified. Other examples of modifiers and additives that can allow for the use of low-quality recycled feedstocks includes a special compatibilizer that can help to eliminate the tiger striping defect commonly seen in recycled TPO compounds. In addition, there's also odor scavenging additives that can help eliminate unpleasant odors that might be present in some of these recycled feedstocks and compounds. As was mentioned in the previous discussions in the packaging market, the demand for bio-based resins is continuing to grow and to grow very rapidly. More and more customers are wanting to utilize bio-based renewable resins in their products. And not surprisingly, these resins are typically compounded with glass or natural fibers, minerals, impact modifiers, and other additives. And while compounding is not specifically a problem for many of the bio-based resins, like Nylon 11, Nylon 10, or Nylon 10 copolymers, it can be a bit trickier for the bio-based compostable resins like PLA and PHA. PLA and PHA are most often compounded to overcome their limitations with brittleness, poor thermal stability, stickiness, low melt strength, and moisture sensitivity. Therefore, these products are most often compounded with impact modifiers and plasticizers, antioxidants, nucleating agents, and chain extenders, which can greatly improve the properties and processability of these materials. Because these materials tend to process very near their degradation temperatures, extra care needs to be taken during the compounding operation to minimize excessive temperature and shear. In addition, these materials tend to absorb a lot of moisture, so proper drying is critical to minimize degradation, which can lead to poor properties, viscosity loss, and loss of melt strength. And as more and more compounders start to compound these materials, especially the PLA and PHA types, it will drive the need for compounding development assistance, which Entec can provide. For my last slide, I have a few compounding examples for bio-based and compostable materials. As mentioned on the previous slide, bio-based engineering polymers like nylon 10 and 11 will commonly be compounded with glass fiber or other reinforcements, plasticizers, and additives like antioxidants and UV stabilizers. Again, there's nothing really different here compared to compounding standard petroleum-based polymers, other than the fact that these polymers are produced from bio-based renewable feedstocks. But as I mentioned, one of the shortfalls with PLA is its inherent brittleness, which necessitates the need to compound in impact modifiers. Entec offers several impact modifiers that can be utilized, and we even have special modifiers that can increase the impact, elongation, and flex fatigue and still provide good contact clarity in a PLA compound. Another example is utilizing a compatibilizer to improve the properties of a PLA LDPE blend. LDPE has been used to improve the flexibility of PLAs, but LDPE is not compatible with PLA. Compounding in a compatibilizer will better tie together the PLA and LDPE and improve the overall properties of the compound. I would like to make one note for everyone. If you add non-compostable polymers or additives to a compostable polymer, it may negatively affect the compostability claims you can make and reduce the overall bio-based content. And now I'll turn the presentation back over to Melissa, who will present the last few slides before we get to the question and answer session.
Thank you, JJ. To summarize today's webinar, we learned that in the automotive market, we continue to support the evolution of automotive plastic advancements by offering sustainable solutions through lightweighting parts and supplying recycled materials that meet quality standards. In packaging, we're incorporating high-performance resins, sustainable polymers such as PCR, PIR, and bio-based resins, as well as novel additives, allowing us to reduce the environmental impact of our packaging while maintaining package integrity. In compounding, we learned that through compatibilization, impact modification, and additives, we can improve the quality of recycled and bio-based compounds. We ask that you please visit our website to learn more about our sustainable product solutions and our line card for this offering. We have recycled resins, bio-based resins, compostable degradable resins, impact modifiers, and compatibilizers for compounding, and a range of other additives, including antioxidants, UVs, oxygen scavengers, fillers, and much more. Please contact one of the presenters today or your local sales rep for more information and to obtain a copy of the line card. To learn more about our sustainability strategy at Entec, please visit our website at entecpolymers.com and download our new sustainability brochure for more information on our 5 core principles of sustainability. And now we'll get into our Q&A section of today's webinar. Feel free at the end of today's session to follow up with any of today's presenters through their contact information here.